Welcome everyone to this week's environmental engineering seminar. Our speaker today is near and dear to our hearts, Professor Shelly Miller, one of our faculty who specializes in air quality. And a lot of you have known Shelly's work for everything that she's done over the last many months regarding the issues with the pandemic and transmission and all of that. So today she's going to be talking to us about her work on musicians and performers. Looking at aerosol formation. So Professor Miller, floor is yours.
Thank you so much. And thank you everyone for coming. And I'm really, really appreciative of this time. I wanted to share our study. We have an amazing research team here at CU Boulder and also partners at the University of Maryland, working with Dr. Yelena Schreberek, Dr. Don Milton, Zhengwei Zhu, and our study chairs are the ones with the vision for this project. We have lead funders. So James and Mark, our study chairs, had this idea that we really had to fund this project and we had to save music. That's what they called me up in June and said, can you help us? And I said, oh my goodness, this sounds like an important project. All of these coalitions came together and donated $500, $5,000 and put together funding, and I've never had any project like it, and it's just been really remarkable. And so we embarked on this study because there really is no data on aerosol emissions from playing instruments, and then that translates into the risk of airborne infection from playing instruments. There is a clear risk from singing due to outbreaks, and so our goal is to save music in schools, and you can see my lead researcher, Taya Stockman, and I in the lab working on the instruments. And then in the middle is a wonderful young musician using our mitigation strategies to reduce emissions. I'll just mention briefly the Skagit Valley choral rehearsal outbreak because this helped us understand that singing was a high risk activity. And we thought, well, goodness, if such an event can happen from singing, is there risk from other performance activities, such as playing musical instruments or performing theater? We have seen many outbreaks over the course of this pandemic due to opera and singing, and so we really wanted to understand this particular outbreak back in March because we thought this was the first real evidence that this is an airborne problem. Because in 2.5 hours with one index singer, we had 87% of the choir members got COVID and 2 died. And so we spent many months talking to the choral members, talking to the facilities managers, talking to the people at the church, gathering evidence, and we have written up our work in the paper now published in Indoor Air. What I want to show you is what happens if we could change the conditions at the choral outbreak, just to show you how mitigation strategies can work. Note that this is based on long range transmission. That is transmission where the aerosol is mixing throughout the space and everyone has equal probability of inhaling that virus. At the particular event, we had 87% infections. That's the first bar. If we add one mitigation strategy at a time, we only can reduce the risk by about 50%. We have a ventilation strategy, and then we have an air cleaner strategy. We can do masks, or we can shorten our time indoors. But each one of them by itself really isn't enough. But if you layer all these strategies and do all of them at once, you can get your risk down to below 10%. And then moving the event outdoors is amazing how outdoors is so much less risky. So we started our research project with trying to figure out what the generation rate would be for performers. And we really wanted to first understand where the airflow is, and then what is the transmission risk of playing these instruments, and how can we mitigate this risk? And we had to jump on this quickly because in August, etc., they start practicing. Marching band starts rolling out, and all of these music programs start happening before school starts. And so we worked really quickly starting in July to start testing all of these types of instruments. And we focused on each instrument with, and then a singer and a performer as well. So we first started with flow characterization with Gene Hertzberg's group here at CU Boulder using Schlieren imaging and laser sheet imaging. Then we also went to plume level measurements. These are plume measurements right at the bell of the instrument. And we also did some amazing CFD modeling from University of Maryland. Here's our Schlieren imaging with the setup and our test chamber. You can see here at SEAL. One of the key things I want to point out is that to do these experiments, you have to have a very, very clean environment. Most environments have 10,000 particles per cc in the environment. It's just there from all the activities and the air pollution inside and outside. But when we're only measuring between 1 and 5 particles per cc from emissions of musicians, you need to have basically no background in your chamber. So that took a lot of work to get that to happen in our facility. So we also then use CO2. We measure CO2, and our workhorse instrument is the aerodynamic particle sizer. It's an amazing instrument that measures between 0.5 micron and 20 microns in size. And we put these instruments together to understand emissions. The results so far are really quite interesting. We have some flow characterization Schlieren video imaging that I would really like to play a little bit of it with you. I'll have to start sharing a different screen though. If I can, we'll have to stop share and see what happens. Because if we can, yeah, there it goes. Okay, let's share a new screen. We've back to I think we'll come back to that. It's feeling like it might be a little bit difficult to get this going at this time. So let's move on. And if I have time at the end, I'd be happy to show you these videos, and they are posted and available. We also did some measurements of velocities coming out of the instruments, and that was helpful in our CFD simulations. And now I want to take you into a deep dive into the oboe, which we have discovered does emit the most particles of any instrument that we have been investigating. And it's for a number of very interesting physics and physiological reasons. The graphs I show you here have the total number concentration on the left and the total volume concentration on the right. And the reason the volume is interesting because that helps us, it's a proxy for mass concentration, because all you need to do is, convert to mass with a density. So looking at the total number concentration on the left, you can see that the top number in our graph, way up to the top left, is 3.5 particles per cc, very low concentrations. And so what we can see is that when we put a surgical mask bell cover on the oboe and we're measuring the aerosol plume, we do not see any sharp peaks in the emissions of aerosols. But when we, but sometimes you can see a little bit in the volume distribution, and we think that's because we see some shedding of some larger particles from the mask itself. Or from the bell cover itself. When you start reading, that's our background measurement, just like speaking, you get a tiny bit of an increase in particles being released. And then when you take the bell cover off and play your instrument regularly, we see these much higher peaks of particles coming out of the instrument. And the peak in this goes up to 3.5 particles per cc, and we have had another instrument measured at 5 particles per cc. This graphic shows our particle size distribution, and I'd like to show you just the highlights. The bright colors show us when the emissions happen, and really what we're seeing from this graph is we are only seeing these high levels of aerosol when there's no bell cover. And so what we're finding is particles between 0.5 micron and about 10 microns in size with our APS instrument. And these are right in the size range of where we expect virus to be contained. We do expect it to be concentrated in the finer particle sizes. So we also look at carbon dioxide because what it helps to us to understand is what's going on with the respiratory plume coming out of the performer and the instrument. When we put a surgical mask on the instrument, we actually see very low levels of carbon dioxide in the plume, and that's because the mask is essentially creating a laminar flow out the instrument, and there's really no big concentration of CO2 that we can detect coming out of the mask, out of the instrument. But when we have no bell cover, we can definitely see CO2 coming through the instrument being carried through by the respiratory emissions of the person. And so we put all the data together for all of our instruments, and these are the comparisons between with and without a bell cover. The bell cover is now our main form of mitigation to reduce emissions. The y-axis is average concentration, and again, number per cc. And the peaks, we are showing time variability with the error bars. So these are about 5-minute tests, and the variability in the measurements are shown with the error bars. And then we average over 50 seconds. And then we do this at least 3 or 4 times. And the bell covers were spandex with MERV 13 material layer and size. The trumpet test, we have 1 test with a surgical mask and 3 tests with sponge and spandex. But consistently, you can see these larger peaks of particle emissions, and then the orange bars are for the bell cover performers. Now, again, note that we do get up to about 1 particle per cc with the trumpet and the French horn. And I want to show you how that compares to singing, and that will come in a minute. Again, our oboe is the highest emitter, with clarinet not far behind. When we started this, and many people thought the flute would be our biggest problem, but it turns out that it's really not, because of the way it's played. So all of these emissions come from your respiratory tract, and with the flute, you're really blowing the air over a hole, and there's not a lot of opportunity for respiratory particles to be formed in from your lungs or larynx or mouth. But with an oboe and clarinet, you have a wet reed, and you have a big back pressure to generate flow coming from your lungs and out the instrument. And we think that combination generates more aerosol. Here are performers. And again, the singer, now we're measuring about a particle per cc in their plume. So it's very comparable to the wind instruments. And the theater performer, when they really started, kind of like very projecting of their voice, they emitted just as many particles as well. And we do see less emissions from a baritone singer, which goes to the idea of there is a very different emissions with different notes. And we do see that. And it's already been shown in the literature of volume is a big indicator as well. We did an averaging of the efficiency for the bell covers, and we see they range between 64% and 95%. This low number for the saxophone is because their emissions are really already so low that there's, dividing 2 small numbers by each other results in this kind of effort. But when we put a mask on the theater performer and the singer, we see very high efficiencies at single pass aerosol release from these performers. So we're still working on the data, and here are pictures of Taya, and this box configuration now is what we're going to use to answer some really specific questions. We put the instrument in the box with the sampling in the box to make the volume of our experiment smaller. To do these experiments in a big room, when you're generating low levels of aerosol, can make it difficult to answer some questions. One of the questions that we keep coming up against is, are there any aerosols coming out of the keys from like a clarinet or an oboe? And we do see airflow coming out of the keys with the Schlieren imaging and the flow visualization. So we wonder if the flow is carrying any particles. But based on these experiments, we don't think it's significant. So if this is now using the box that I showed you in the picture in the previous slide. So the first two peaks are where the bell is uncovered and the bell and the lowest keyholes are in the box. And we do see this peak, but mainly because the bell is uncovered. The bell cover is then, with the bell covered and the bell and the keyhole in the box, we do see a significant reduction consistently, whether you have the keyhole and the bell or the
Hey, let me try to
Yeah.
stop this.
And then when we go back to the bell uncovered, we do see another peak. So using this data, we do decide that the keyhole really is not a significant source of aerosol, which is great because trying to cover those keys is really difficult. We tested a bunch of bell covers, and what we're trying to help musicians understand is what kind of bell cover to use, whether we should use a surgical mask, which is this lower peak here, or the cloth bell covers. And so, you know, it does matter what kind of material your bell cover is, just like it matters what kind of material your mask is. Here is data with the baritone singer, and what we want to show is that if you know how you put your mask on and it's not super well fitting, there might be some gaping around the side of the mask. If we probe that side of the mask, we can definitely see that there is aerosol leaking out the side of the mask. So always, you know, ensuring that you can wear the closest, tightest fitting mask possible. We do recommend that our musicians also play with masks. I'd like to carry on with the computational fluid dynamics modeling. It's really cool. It's so impressive what they have been managing to do. I think it's cutting edge. So we've done outdoors and indoors, and then also a rehearsal room. The outdoors setup looks like this because we want to know, you know, what we do a lot of marching band outdoors, and what do we need to do to keep marching band players safe, even if they're playing outdoors? And we look also at the effectiveness of ventilation and masks. This is showing us the risk using the Wells-Riley modeling equation, which is what we use to estimate risk in our Skagit Valley Chorale Outbreak study as well. And so the dark blue is very minimal risk. And as you go up in color, you increase the risk. This is a singer playing into the wind about 2 meters per second and starting to generate an aerosol cloud behind them. Over 30 minutes of singing, which, you know, is a little bit long for singing, but still we have constant singing. We do develop a plume behind the singer at about 1 meter length. And this is over 30 minutes, and we double or triple the risk within this aerosol plume. And over an hour, it spreads out even further. When we put a mask on, a 64% efficiency mask without, you know, we do model a perfect fitting mask here. We see a significant reduction in the plume. When we go inside, the upper bars are showing a top-down version of singing without a mask, and indoors with a ventilation system operating about 3 air changes per hour. We do see that over the course of 30 minutes and then 60 minutes, quite a bit higher risk throughout the room being. When we put the mask on, the risk is much lower. But based on this work, we have recommended to all our musicians, in the interest of being the most safe, to practice for only 30 minutes at a time, to stop practicing, allow the room to clear out by ventilation for 1 air change, and then start practicing again. And this is just a side view showing some of the different modeling. We then wanted to model a University of Colorado Boulder rehearsal hall, and this is actually at our campus, and it's a real simulation with singers and actual ventilation. So we have the ventilation coming in at the top of the space, and the outlet is down at the bottom of the space. It's a very interesting design. And then P1 is our index case, and they are the infected person. And then we really model all of these players and and singers to see what happens. And it's just fascinating, a very difficult modeling effort. So what we see without a mask and with a mask is that the risk, which is related directly to the viral concentration in quanta per cubic meters now, does change depending on whether you have a mask or not. The pictures on the upper part of the graph are showing the streamlines of the exhaled airflow. And then the lower diagrams are the ISO concentration surface with and without a mask. And the mask does definitely reduce the amount of aerosol being, released from the singer. And we've estimated the protection for each singer with a mask. And what we see is that, we are able to reduce the risk, especially for a person too, who's standing right next to the index person, by 85%. And then we reduce the risk for the other singers as well, because they are, farther from the person. But this is still the well-mixed show the risk under perfectly mixed ventilation conditions results in an underestimate of risk. So we are, CFD is an important tool in understanding how virus flows through the indoor environment. We also simulated the playing of clarinets and a director, right? This is really cool, where we also have the emissions from the clarinet. But what's interesting about this is because the clarinet is at a lower level of emissions than the singer, and the ventilation system is drawing air out at the bottom of the room, it decreases the risk by quite a bit, just that little change in the height of the emissions. And we do see that bell covers are helping to reduce the risk, and we estimate about 64% using the bell covers. And so that is quite an interesting result. And the ISO concentration is really quite low with the bell cover. So in final conclusions, and then I'm happy to answer any questions or talk about ventilation or filtration or whatever you want. We do see respiratory aerosols emitted when playing wind instruments, singing and performing, and they're on about the same level, but some instruments are actually quite a bit lower. But ranging between 1 particle per cc upwards of 5 particles per cc, and we will be developing emission rates. Most of the aerosol comes out of the bell, and they're all comparable. This is a picture from St. Olaf's College, where they are using our mitigation strategies, and I wanted to highlight these based on our work. We recommend that everyone performs with a mask, that you also perform with a mask with an instrument, and you also have a separate mask to put on if you need to talk. But this helps protect your nose from inhaling any potential virus and also from releasing large droplets. You need to use a good mask for all of this. And we do recommend playing outdoors and indoors for only 30 minutes. Using proper hygiene, we should ensure good ventilation and air cleaning, and using distancing in our performances. And just by anecdotally, I'd like to share with you that we've been tracking outbreaks and transmission happening in programs that are using our mitigation strategies. And we have yet to report a single case of transmission, although we do know of 2 cases where a trombone player came and rehearsed while infectious, and 2 clarinet players came and rehearsed while infectious, but yet nobody within the space that was practicing with them got infected. So that just shows that, our mitigations so far are working great. And, until we can solve this pandemic, we do need to be careful with high emitting aerosol activities. So I left up quite a bit of time now to answer any questions and talk about any other topics that you would like. So that's all I have for now. And I can turn it over to you, Fernando.
Thank you very much, Professor Miller. I'm going to turn my own light over here. For the Q&A, if you can either write a question on the chat function, otherwise there should be an option for you to raise your virtual hand, and then I'll call on you. We want to do this in a way that is structured and fair for everyone. So first question from Richard Berman. Has anyone qualified the sound quality damage due to various mask types?
I have not seen that work. I think that's quite an interesting question. Our performers do report to us that they don't feel that impacted by performing with the bell cover, or but of course it's an individual perspective, but no.
Thank you. From Professor Mansfeld, for those instruments that have them, what are the speed valve protocols put into place?
Yeah, good point. We recommend everyone using puppy pads, and you put those under your spit valve, and then gather that up and throw it away every time you use it.
Great. We have a virtual hand raise. One of our students, Julia, go ahead.
Hi, so I had to come late because of midterm, so forgive me if this question was answered in the presentation, but I wanted to ask how factors like humidity and dew point were incorporated into the experiment.
Thank you, Julia. Good to see you. Right now, we do not measure relative humidity or worry too much about relative humidity. In conversations with my aerosol colleagues, because the data on virus activity with regards to relative humidity seems to be a little bit up in the air. This is actually talking to my expert colleague, Lindsay Marr, based on her experiments. We think relative humidity is a secondary effect, and we don't worry about it. We're focusing mainly on ventilation and filtration, not worrying about relative humidity.
Thank you very much. Question from Jonathan Crane. Can getting ACH up to 10 times per hour reduce the need for 6 feet spacing? Obviously, nothing you can do about potential sneezing and coughing.
So we see that getting up to 10 air changes per hour really reduce the risk of long range transmission to very low risk. However, it does not affect short range transmission. So I'm not recommending reducing the social distancing. Short range aerosol transmission has no, ventilation does not solve that problem. Ventilation only solves the bigger room problem. But as you come closer to a person shedding high amounts of virus, you put yourself at higher risk. So I still do not advocate for reducing any kind of social distancing norms.
Thank you. Next question from Tanya. Can these practice rooms be optimized by placing musicians strategically around HVAC systems?
I think I'm not sure I'm getting that. Is it in the chat?
Yes, it's in the chat. It's whether you can just move people around the HVAC system to make sure that transmission is minimized.
It's sure. I mean, it's hard to. Most ventilation systems supply air in the ceiling and exhaust it in the ceiling as well. And they treat the room as if it's well mixed. It's sort of a well mixed ventilation practice that most rooms are. So generally speaking, I don't think that would make a huge difference.
Thank you very much. David Kravitz, curious whether you have an explanation for the surprising difference between soprano and baritone singers.
Yeah, we see that that there is a difference in the notes you're playing from every performer. So for example, when you play a high note on a clarinet, you do seem to get a lot more aerosol, and then singing higher seems to also emit more particles. So right now our hypothesis is kind of the notes you're playing. really are resulting in different emissions. But we have yet to work out the why that is.
Thank you. Ryan, hi, Dr. Miller. I really enjoyed
Hi, Ryan.
the presentation. I was curious, is the recommended spacing takes into account certain instruments that have unorthodox angles, such as the flute? Also, did your study happen to take into account the streamlines from whistles, such as those used in the marching band?
Oh, interesting. No, we didn't think about the whistles. And Ryan, you are a performer, so right? What do you play again?
Ryan, you can unmute yourself and speak up.
I've seen you in the band.
I know he's around.
Yeah. Anyway, we did not account for the angles and what have you with regards to our recommendations on distancing. And there are recommendations for the flute, especially from the NFHS website, where we have provided all of our mitigation strategies. And I think they do recommend still a small cover over the end of the flute as well.
So I'll provide an update. Ryan plays the trombone.
Yes, I knew it.
All right, from Russell Martin, for a streaming performance on a stage, a large hall, what spacing should you have between the singer and musicians?
Oh, so interesting. Large halls, have such specialized ventilation systems, but I still do think that we should stick with the at least 6 to 12, 6-foot distancing. Here at CU, we've actually implemented a 12-foot distancing based on a CDC recommendation for aerosol generating procedures. So I do think needing to stick between that if you can. I hope that's answered your question, Russell.
Russell, you have a follow-up?
Yeah, it was just around if we're filming a live streaming event where we want the performers just for the filming part to be without a mask, what's the safe distance spacing in that short period of song that we can have them where they're away from the film crew and spaced out from each other, assuming that we have a large volume of space to do this in?
Yeah, I mean, you saw those CFD simulations where, at over a half hour, you can generate a plume of about 3 feet, in distance. So, sort of based on that information would be where I might draw your conclusions for what you would like to do.
But if we had like 12-foot spacing distance and we have about a 3 times an hour turnover in our venue, that would...
I think that would be reasonable.
Yeah, thank you.
And I see Elva asked about ceiling height. Does ceiling height impact the study? And I'm really glad you asked this ceiling height question. A colleague of mine is writing a paper on that right now. Ceiling height is really important because the bigger volume you have, the more space you have for the contamination of the virus to be mixed in, and then the concentration will be lower. So the higher the ceiling, the lower your risk just automatically. So it really does impact your risk in a space. However, a larger space also has implications for how you estimate air changes per hour. I still think we stick to the 30 minutes right now, just because of trying to be consistent with our guidelines and keeping it straightforward. And integrating ceiling height is important, but a little bit more complex.
I'm gonna take the next question here. So there's actually a question here about yodeling. So Professor Manfeld, with the recent super spreading event in Switzerland, is there any way to yodel safely? Or some singing styles that are just inherently more dangerous? This is a very important topic of discussion.
Yeah, I mean, I don't think you should do any of that stuff without wearing a mask. So I think for the next year you could yodel with a mask.
Thank you. Let's see. There's a question here from Steve Morton in New York. He was wondering, for the mitigation strategies you mentioned, ventilation and filtration if we need to take into account the airflow that results. He's thinking about a Chinese study of the restaurant with air conditioning and downstream infection and wonder if this can create complications or does the filtration overcome this?
Yeah, I don't think that, I think if you have a strong airflow pattern that's blowing virus from a person that's infected to other people, that's a really high risk situation, and you should minimize any strong airflows in a space and make sure you do not have that happening. There was no ventilation in that restaurant at all. And so once you start adding ventilation, you start decreasing the overall concentration of the virus and improving the safety of the space. So your first task would be to get rid of any of strong airflows and then improve your ventilation. I hope that answered the question.
So actually the next question is broadly about whether you can address engineer ventilation system versus just having windows open for ventilation.
Mm-hmm. Yeah, so the reason that you have the mechanical ventilation, and here in the US, we love our mechanical ventilation systems. Unfortunately, they also cost us like 30% of our carbon budget to condition a space. Natural ventilation is much more common in Europe. The mechanical ventilation system controls the airflow that comes into the building and provides it consistently over the course of the use of the space. It depends on the outdoor temperature as well. But most spaces are ventilated around 3-ish air changes per hour with some recirculating airflow. When you open a window, you can increase the air change as well, up to 3 to 5 air changes, depending on how many windows you have open. It's a little less consistent because you do need a temperature difference to drive the airflow. So a lot of people, but we see lots of high air change rates with natural ventilation spaces, and I would advocate for that when you can.
A question from a student: have you looked at any data from dancers? Can the CFD model be used for moving people?
Yeah, the dancing question is super interesting. I do not think CFD can be used to do that. I think we would need to do, actual flow visualization of some sort to do dancing. Our next experiment is to do vigorous. It's going to be simulating a performer that does musical theater. And we've been struggling to design this experiment because of the background particle levels that get generated when people are moving because of particle resuspension. So I just ordered a stationary bicycle, and we're going to be simulating, I guess we could use that to also simulate dance, but I think that's a really important question that I don't have the answer to, and we are not specifically looking at that as well.
Cool. Next question: theater rehearsals usually last 3-4 hours. Would you recommend breaks every 30 minutes to allow air exchange when rehearsals must take place indoors?
Definitely, that's exactly what we recommend. You practice for 30 minutes and then you break for an air change. A colleague of mine wrote a paper on why this is more effective, and it's a great paper, but it does show that if you do 30 minutes of activity, then allow the room to clean out a little bit, and then add 30 minutes, that you can reduce your risk by up to 10% to infection, and I think that's worth doing.
Let's see. There's a comment about whether when we discussion about yodeling, whether we were dismissive about it. Indeed, that was not the intention.
No.
We recognize the importance, how comparable this is to other forms of culture, and the recommendation was essentially that given the high flow, that this is probably something that should be avoided for the time being.
Yeah, I apologize if my answer seemed like I was being flippant. I think I was laughing because I think everything needs to be used. We need to do a mask with everything that generates aerosol, and whether it's talking, whether it's singing, and whether it's yodeling or playing music right now, because everyone could be infectious. And apologies if that seemed flippant.
Is there a simple way to measure air exchange in a room?
No, sadly. One of the things that we're recommending that is easier for the community is to measure carbon dioxide. And if you measure the carbon dioxide in your room, then you can get a sense of whether you have reasonable ventilation. And to measure an air change rate, you need a tracer, and you need to elevate the content of the tracer to a high level and then watch it decay with time and make measurements with time. And so there are ways to do it with carbon dioxide so I'm happy to help with that. But in general, if you measure CO2 indoors, at this time, I recommend it should be between 600 and 800 parts per million.
Let's see. You're talking, things are moving quickly here. You're talking about braking for 1 air exchange, but I've heard previously that braking for 3 air exchanges is preferable. Can you comment on that?
Yes, so for our students here, I will comment that this is based on the completely mixed flow reactor material balance that we use and that we teach in environmental engineering. And it has to do with the exponential decay of concentration in a room when you're using ventilation. So with 1 air change per hour, you reduce the concentration to 64% of the peak based on the exponential decay. And for 3 air changes per hour, that's when you get to steady state. And that's when you have completely cleared out the room. So, if you have a room that has a half an air change per hour, then it takes 2 hours to get down to 64% and 6 hours to completely clear out the space. Whereas if you have a 3 air change per hour room, it's only 20 minutes to get to 64% and 1 hour to get to the full cleaning of the space.
All right. Shelly, I'm trying to read through these and pick up another one. Here's one. In my school, the flutists are using the little cover you mentioned and also plastic screen that they place over their mouthpiece. Do you think that this second thing has any effect to limit aerosol spread? Because it affects the sound badly. Thank you for your wonderful presentation.
Oh, thank you so much. We haven't tested the efficacy of those devices, so I can't comment on whether they are, needed really. But what I would say, is when you are projecting a lot of air out of your mouth, you can release larger droplets. And so I can imagine that that's why the device is used. And I also think the little thing on the end is probably reasonable as well. So being the safest, I'm sure that's why those are suggested for players, but we haven't done any measurements with them.
There's a question here from Christopher Mosley. So if we don't have CO2 info or ACH, what do we do? And number 2, for rooms with drop ceilings, should we remove some ceiling tiles to open it up some?
I think that's a pretty creative idea, Chris, to remove the ceiling tiles to open it up some. Yeah, if you can, that's pretty creative. If you don't have CO2 monitors and you don't have an estimate of air change, that is difficult, I would say. And if you don't have even a chance to open a window, it seems really hard to know whether it's gonna be safe in there or not. That is a really tough one. If it's a mechanically ventilated space, you'll probably have at least 2 to 4 air changes per hour, I think. So unfortunately, I don't know how else to solve that problem. Then I'm just thinking, like, I wouldn't use that room. If I don't understand what's going on with the ventilation, I wouldn't play in there or use it. I would move to a different space.
So to follow up on the ventilation inside rooms, a question from Alan Adinoff. In addition to having open windows, are fans useful directing airflow towards the open window?
Yeah, I have been okay with recommending that box fans be put, close to a window and blow air out of the space when it's occupied by other people, because that will help with this airflow needing to be driven in order to enhance the ventilation when your window is open. And so, a fan blowing air out, I think, is a reasonable approach, and have been recommending that, yes.
Here's a question about CO2. So from Steve, we can measure CO2 to get a sense of freshness of the air. But if we are relying on HEPA filtration, I guess we need to measure particles. Any cost-effective alternatives to measuring CO2?
Yeah, that is a caveat, and right now there's no way to solve that problem for the average community member. Knowing that the CO2 is a tracer for how good your ventilation is, and then adding the air cleaner will just reduce the particle levels even further, but you won't see that impact with your CO2. And if you have tried to, one idea I had is have your space be occupied and measure the CO2, and then the air cleaner will add an additional 3 air changes per hour if you have purchased the right size.
A question from Becky Hughes. My classes are 82 minutes long. Will it be acceptable to rehearse inside for 30 minutes, stay in the room and do work on computers for 20 minutes without playing or talking, and then play again for the rest of the time? Or is it better if they leave the room for 20 minutes?
I think it's fine to go ahead and not, the point is you don't want to be generating aerosol for that 20 minutes and let the room and the ventilation clear it out for you. So if that's the, I think that approach would be fine.
Are there, from Richard Berman, are there inexpensive, reasonable, accurate CO2 meters available?
Yes, there are. They are under $200. Many of them are sold out, but the Aeronet 4, for example, has a lead time of 2 to 4 weeks. And but I was able to purchase a couple of different kinds to practice with, and they are available. And you want to have a NDIR technology, so non-dispersive infrared technology, that is plus or minus 50 parts per million, and you can get them for under $200.
Perhaps 1 or 2 more questions. In addition to having open windows, are fans useful directing airflow towards the open window? I'm assuming the answer is yes on that one.
Yes, that is what I do recommend. And if I might make a comment on the DIY air cleaners, we are promoting the use of basic HEPA cleaners to supplement ventilation. There's been a real surge in a DIY air cleaner culture, which is awesome. The problem is you don't know what the clean air delivery rate is of a DIY air cleaner. When you take a box fan, the fan has not been built to overcome a really high pressure drop. Then you slap a HEPA filter on the front. It causes a big pressure drop on the fan, and so it may not be pulling enough air through the device to provide you with the clean air delivery rate that you are looking for.
All right, I think we've covered most of the questions. Any final questions for Professor Miller?
I did see a seat ask a question about the 2 masks, and I might just comment on that because I figured out why that's important recently as well. It's a recommendation from our project sponsors, and it makes a lot of sense. You have one mask that you're using to play with a slit in it, and that you have droplets being collected, but you still have a little bit of an airflow opening that won't resist aerosol. It will be released from there. And then the mask is covering your nose. But when you stop playing, you take that one off and put the regular one on so that you can speak and talk to the conductor, what have you, and not be worried about aerosol being released.
Right, we got a handful of more questions. Can you say more about outdoors versus indoors? Still 30 minutes, even if you're outdoors?
Yeah, still 30 minutes, but we have recommended just a 5-minute break because there's so much airflow. But after 30 minutes of playing, a plume does develop around your performer, and you want to let that dissipate for a few minutes before you start again.
Any recommendations for air purification devices in HVAC systems?
So in HVAC systems, because the fan has often not been built to overcome the pressure drop from really high efficient filters, you have to be a little bit careful to try to improve your filtration. Most systems have something called a mervate. It's not super efficient against fine particles, but it's better than nothing. And if you can increase that to a higher MERV without damaging your blower, that's my best recommendation. I would then move to using a germicidal UV light in your HVAC system. They are commonly used, and they are there's lots of scientific literature on how effective they are. There has been a lot of bipolar ionization devices and other ionizer devices out there being sold on the market. There's not independent research to show that those are a scientifically viable approach, but they are, there are reasons to think they could be, but I'm concerned they're going to release ozone and other cause other indoor air quality problems. And because we don't have a large literature body of scientific evidence to support them yet, I don't recommend them.
For those of you asking, I'm sharing on the chat function the website for the EVN YouTube channel. This presentation will be posted there after a few days for processing.
And if I could add that all of our, this is unprecedented to do a scientific study and release data before it's been peer reviewed and publicized and published, because we just felt you needed to see our data and you needed to know what was going on so that you could make informed decisions to keep your musicians safe. The third installment of our results are pretty cool, and they are just being released today on the NFHS website. And there's a video there with an interview of myself and Dr. Schlieren.
Perhaps, Becky Hughes has the perfect last question. At what point do you think we'll be back to how things used to be?
Right. I had this discussion earlier this summer with my colleagues, Dr. Vance and Dr. Marr, and I said, sorry, colleagues, I think it's going to be 3 years. And they were so mad at me. They said, no, it's going to be a year. It's going to be next summer. But I think I'm more right than they are right now, because things are getting worse and worse and worse. And the vaccine is coming. Unfortunately, the US has given up, has decided, and there's so much virus around, it's going to be very hard to crawl back from the precipice we are on. And I'm really concerned. I can't imagine we're going to get back to normal by even next fall. And I'm really upset about it. But I'm still smiling.
All right. So thank you everyone for joining today in this seminar. Like I said, it was recorded. It will be posted after some time for processing. And thank you to Professor Miller for the presentation.
Thank you everyone for coming. I appreciate your attention, and have a great weekend.